Okay, everybody, welcome to this third and final video about measurement and data processing. And so in this last segment, what I'm going to talk to you about is percent error and also how to deal with the uncertainty numbers when you add, subtract, multiply, or divide values. So we'll get into that. And then we'll do a little bit of graphing, which we'll mostly do in class because you really need to actually sit down and do graphing, but I'll introduce the idea to you so that you know what you're in for. So when I talk about percent error, you've seen this last year when you did honors chemistry or 2 years ago. And so in the numerator you have the percent error. And that percent error, you have the error. And so what you're doing is you're taking your measured value and subtracting it from your accepted value, or your accepted value minus your measured value. You're going to do the absolute value of that. So you'll always have a positive percent error. Then you divide it by the accepted value, and then you times it by 100. So this gives you an idea of how accurate your result is in terms of the percent correct. So here's an example where they give you 99.2 degrees Celsius as the measured boiling point. And then the accepted value is 100. So they subtract the measured minus the accepted, and then they divide it by the accepted and times it by 100. So the difference is 0.8 divided by 100 times 100, so then the percentage is just 0.8%. So that's a pretty good percent. That's a low percent error. Is there a cutoff for, is it accurate or not accurate? Not really, but at the same time, though, you need to comment on how close your result is to the accepted value. Now, what do we do when we look at uncertainties where we have some kind of calculation? So the first kind of calculation that we're going to do is the easiest one, and that's addition and subtraction of two values that you measured. So, like with these, it's really quite simple. Over here we have grams. So I measured the, let's say, crucible with a sample to be 111.28 grams. Just underline that one. And my uncertainty is 0.01 grams. It's based on the balance. This is an electronic balance. You can see the last value here is in the hundredths place, and so it's plus or minus 1/100th. Now let's say that I took another value, let's say I heated the crucible and some of the water evaporated from the sample, and in the end I'm left with my dehydrated sample. And when I do that, I also have an error or an uncertainty, and that's again 0.01 based on the smallest increment. Now if I were to subtract these two values, I would get 10.05. And the thing that I do with this is I add the uncertainties. So if the first sample was 0.01 and the second one was 0.01, together the total is 0.02. Now then they have another data set. So this was trial 1, trial 2, trial 3. In trial 2, they're doing the same thing. They're subtracting the before and after. Notice again, they add the uncertainties. Now in trial 3, they do this just for fun. They change the uncertainty to 0.02. I'm not quite sure why, but we can just do that just to prove the point here. And so when we subtract these two values, we still add the uncertainties, but notice the uncertainties now are 0.04. Now if I take these three numbers right here and I add them, I also add those uncertainties. So if I were to add these three values here to get a total of 30.20, my uncertainty would be 0.08. So to put this simply, what you're doing is whenever you add or subtract, you just add the uncertainties. Notice there's the term absolute uncertainty. It's not a percentage, it's an absolute value. And that's going to be your final answer. It's that straightforward. So hopefully if you're just doing data where you're subtracting a before and after, then you can add the uncertainties. Now, what happens when you have a situation where you're going to multiply and divide? This requires more work. It is not difficult. It is just a little bit tedious. So what you have to do is you have to actually change the absolute uncertainties to percentages and then change it back to absolute uncertainties. And so when I look at this, let's do an example. Let's say that I multiply together these two values, centimeters, to get an area. So I have my 2.4 and my 1.3 centimeters. And so in this case, I need to account for the uncertainty. Well, what percentage is 0.02 of 2.4? Well, it's 8.3%. This is the math right here. So first I find the percentage. So I take the uncertainty and I divide it by the value. And we can write that out here. To do the percentage, I do the uncertainty divided by the value of the number, value of measurement. And then I would times that by 100. And I would do that for the other value too, for the 1.3. So now I have my 2% values here. So I have this percentage and this percentage. So what do I do with those percentages? Well, the second step is to add them up. So my total percentage is 23.7. Now, I multiply the math. I multiply the numbers, do the math. So I multiply the numbers, and this is my area. So this would be centimeters squared. And there's quite a large percent uncertainty there. But now I can convert that percentage back to an absolute value. So now I have my absolute uncertainty. And notice what I do here is I look back at the absolute uncertainties that I started with, which was 0.2 and 0.2, and I change my new absolute uncertainty back to one significant figure. I also round this number with the correct number of sig figs. So when I do this, I look at each value separately. Think about these steps. I take each value and I look at the uncertainty and I divide it by the measurement. So that's this step here. It gives me a percentage. I then add the percentages. I then perform the math to get my value with the percentage. I leave it as a percentage at that point, and then I change the percentage back to an absolute value, and then I round properly. So a lot of your calculations are going to be math calculations where you're doing, division and multiplication. And so you're going to have to do this. The good news is that we can use some program like Excel, and we can actually have it done for us if we program Excel. So if you're taking, 15 measurements, you don't want to do this 15 times, right? So we can spend time in class doing this for Excel. So now, to put this simply, I'm going to take these absolute uncertainties, I'm going to calculate the percentage, I'm going to add up the percentages, and then I'm going to convert it back when I have a final answer. So let's try one, like, here, I'll give you one to do, and you can pause the video and you can try it. And so what if I were to give you something like this? What if I were to give you, let's see here, you had a 20, you had a 20 gram sample plus or minus, actually, you know something? Let's do this like we were really measuring it. Sorry about that. So let's say that you had a 20.13 gram sample of, some kind of metal, and the uncertainty was plus or minus 0.01 grams. and then you measured the volume of it, and you measure the volume in, milliliters, and you had a volume of, let's say, 2.3 milliliters plus or minus 0.05 milliliters. And I ask you to calculate the density. And you're going to calculate the density, mass over volume, but you also need to calculate the overall uncertainty. So give that a try. We're going to go over it tomorrow. Let's see how you do. Now, let's take a look at our last thing. Perhaps this is how you're feeling right now. This is how I would be feeling when I was doing one of these problems for the first time. We're going to practice a lot of these in class. I'm not going to tell you that they're going to get any less tedious, but they'll get easier as you practice them. So the last thing that I want to talk to you about briefly is graphical techniques. There's two kinds of graphical techniques that you're going to be required to do. One is like a sketched graph. We do this all the time. Here's resistance versus temperature if you're talking about viscosity or something like that. But we do this all the time when we do something like, Boyle's law. Remember what Boyle's law is? Think about that one. Pressure versus volume. So we have pressure and we have volume, and then we graph and then we have our sketch like this. Or we do volume versus temperature. So, we have our temperature and we have our volume, and we go like this. Let's do a straight line here. Now really, I should put in units. That would be nice, but I don't have to. I could just put it as, volume and temperature. You don't need that, it's just a sketch. The idea is to show the trend. You want to show that there's a trend, direct, inverse. You want to use those terms, inverse, not indirect, and direct. Now, when we do a graph that we actually look at data, we're going to put in all this detail. This is the stuff that you really should be looking at. Well, do I have my axes labeled? Do I have a title? And that isn't here, but we should put that in. Do I have a title? Because if I don't have a title for the graph, then what's the point? Did I display the units? And with this drawn graph, I should be able to calculate the slope, the y-intercept, the best fit line. And so here is, a scatter plot, as they call it. That's the name of this, a scatter plot. Rainfall in Tennessee per year. So notice they have the year, they have the rainfall in centimeters. They don't put in error, and they really should, at least for rainfall in centimeters. But if I wanted to draw a best fit line for this, if I wasn't doing this on the computer, well, I would have to put in my best fit line. So I would put in my best fit line. I could calculate the slope, change in y over change in x, and I could write a y equals mx plus b. But let's be realistic. You're never going to do this. You're never going to, by hand, have to draw in one of these best fit lines, because we're going to use a program like Excel. And so here's my data, and I can graph this in Excel. So notice my table, it has units, it has titles. Something's missing from it. I'll let you think about that. But when I graph this data, here it is. So look at my graph. Tear it apart. Tell me what's good and bad about it. What's missing from it? I can tell you right now, this graph used to have an equation on it, and now it's gone. I don't know where it went. But you look at it, you tell me. I want to talk about it tomorrow. I want to know what's missing from it. I'd really appreciate hearing what you have to say. How does this relate to your IA? Because this is really where you're going to be doing graphs. You're going to be doing it in the labs, you're going to be doing it for your IA. Well, let's look at an IA. This is a sample IA that was released by the IB powers that are, and they have this one graph from one of the IA papers, and it has a title to it. It has data points here. It has a best fit line. It has the equation that my graph above was supposed to have but didn't. It has a correlation coefficient. It has axes that are labeled with numbers and titles. So this graph is pretty complete. A few things missing, but it's pretty complete. When you do a graph, this is what you need to be able to do. So, ask yourself this question, can I graph with a computer? What we'll do tomorrow is we'll talk about the errors, or the uncertainties, and we'll do problems with that. But then we'll ask ourselves, what programs are people using on a computer, and we'll share that. If you use Excel, that's great, because I love Excel. I think it's powerful. But there are other programs out there that are equally beneficial. So this is our first chapter. This was broken up into 3 videos. This one went a little bit longer than I wanted it to, but I want to make sure that I'm thorough with you. I'd like your feedback if you thought that this was useful. Some people like it, some people don't, but I'd be curious to hear what the majority of you think. And when you use these, you really need to spend time looking at them, pausing them. If you get bored of me, then stop. Take a break. Come back. Do some practice. You don't need to sit there like you do in class and just listen to me. And if you stop me, you can start me again. Class, you're bored, you get up to go to the bathroom, you come back, you miss something. Here you didn't miss anything. So I'm going to put all these notes up on iTunes U with my writing. This particular slideshow, I did not write a lot. In some of the other more intensive mathematical ones, I do write a lot. All right, good luck. Thank you. See you tomorrow.